This video is over topic 6.2 over parallel and perpendicular lines day 1. So they ask us to use the graph below to find the slope of each line, and that has already been done for us, so we're just going to look at this table. For line A, the slope is up 1 over 3, B is also up 1 over 3, C is 3, so up 3 over 1, and then D goes down 3. And then the equations are listed for us with the slope and the y-intercept. The first thing they ask us is which lines are parallel, and we have a friendly reminder that parallel looks like two L's that never ever ever cross. So the two lines that look parallel are A and B. These two right here look parallel. They look like train tracks. If a train was going here and here, those trains would never run into each other. And what do we notice about their slopes? Well, their slopes are the same. And I'm going to put that they are the exact same because that does make a difference. And then they ask us which lines are perpendicular, which means they cross at 90 degrees. Not just that they cross, but that they make a T. Well, the ones that make a T are D with A and B. So right here and right here. So D and A, D and B. And then looking at their slopes, we already talked A and B have the same slope. And then D has a negative 3. So that would be the complete opposite. So the sign changes and 1/3 flipped to become 3. So we could say that the sign changes and the number flips. Now some teachers like to call this a flop, a flip, and an opposite. So if your teacher calls it that, that's what we're talking about here. Ooh. So in the bottom, they ask us to fill in this chart. So we just discovered that parallel slopes have the same slope. So 2/3 would be parallel to 2/3. -4 would be parallel to -4. -1/4 to -1/4, 2 to 2, and 0 to 0. And then the perpendicular slope we just saw was the complete opposite. It's technically kind of called a negative reciprocal, but instead of the word negative, we're going to use the word opposite because we're talking about the sign. Reciprocal means you flip the number, and then instead of negative, we're going to use opposite. So the opposite sign and a flipped number. So 2/3 would flip, so 2 was on top, 3 is now going to be on top. It was positive, so now it will be negative. With -1/4, it's now going to, with -4, it's now going to be a positive 1/4. We have a little note right here that when you flip a whole number, it becomes a fraction. And so when we flipped 2, it flipped to a -1/2. So remember that all numbers are over 1. We just don't write it that way, but when you flip them, whatever big number you had would go on the bottom and 1 goes on the top. So -1/4 flips to be positive 4/1, so we just write it as 4. 2 flips to be -1/2. And the opposite of 0, remember 0 is a special case, so that would be a hoi. The opposite of hoi is vux, and the slope for a vux would be undefined. So those are some special cases down here on the bottom that we are really going to hit on day 3. So on the back, they ask us to determine if the lines are parallel, perpendicular, or neither. So remember, parallel is the same slope, perpendicular is the complete opposite, or there's also an option of neither. If it's not exactly the same or the complete opposite, then it would be a neither. So problem 1, we go from a negative to a positive, from a 1/2 to a 2. Those are complete opposites, so this would be perpendicular. On problem 2, we have 3 and -3. Now my signs change, but my number does not flip, so this is going to be a neither because it's not the complete opposite or the exact same. And then on problem 3, we have 1/7 and 1/7. Those are the exact same, so that would be parallel. So problem 4 asks us to write an equation in slope-intercept form of a line that passes through the given point, 2, 9, down below, and is parallel to the graph of the given equation. So what's happening is we have a line and I'm going to draw this really rough, but it starts at -4 and it goes up 5/2. So this is the line they gave us. Now they are asking us to use this point 2, 9, so like this blue point way up here, and come up with a completely new equation that is parallel or looks the exact same to the red line that was already given to us. Well, we know that if we have a parallel line would have the same slope. That's what we discovered on the front. And so what we're going to do are these steps right here. First thing we're going to do is steal the slope. Parallel is the same slope, so I have my slope of 5/2. Now I have a point that was given to me and a slope. And so I'm going to use the slope and the point and put it in point slope because that's what I have. So I plug in my slope and my new point. Notice that my original line had -4 and that is nowhere in my equation. So the -4 really just tells us what the original line started at, but has no importance in this point slope form. In order to get into slope-intercept form, which they asked for, we distribute 5/2 x to both sides and get 5/2 x minus 5. And then we continue solving for y by moving the -9. We add 9 to both sides, and -5 plus 9 is a +4. And I wrote here, it is just a coincidence that the 4 is the opposite of -4. That is strictly a coincidence with these numbers. You can always get something like +8 or -16 or 15 or something that's not even divisible by 4. So it is just a coincidence. We can't just say, oh, you just changed the b value to be positive, because that's not true, and we're going to see that here in a minute. So problem 5 wants us to do the same thing, slope-intercept form that goes through the given point but is perpendicular to the graph. Now the way I remember it is the longer the word, the more work we have to do. So you'll see it in a minute, but once we're done, compare the work on 5 and the work on 4, okay? So my slope needs to be completely flipped. So my perp slope is going to be this but flipped. So 9 is going to be on the top, 2 is going to be on the bottom. Remember, it is the complete opposite or the opposite reciprocal. It started positive, so it will be negative. Once you write your slope, you are done with this line. You do not need it anymore. And so I encourage students to lightly cross it out where you can still see it in case you made a mistake and have to start over. But it reminds us that we don't need that -5 for anything. And now we're going to use the point 6, -13 as our x1 and y1. We plug into point slope form, so it's a good thing we just did a lot of practice on that. So y minus y1 equals m x minus x1. Okay, so again, I need to solve for y because if I look, all of my answer choices are in y equals. Now, just briefly glancing at my answer choices, I remember that perpendicular has a complete opposite slope, and so looking at my two answer choices, B and C are not complete opposites, so I can immediately mark those two options out because there's no way that my slope could be perpendicular but be exactly the same. So what I'm going to do from here is distribute -9/2 times x. -9/2 times -6 is a positive 27, and then minus minus is really plus. And then my last step is to subtract 13 just from the numbers, not from the x's. And 27 minus 13 is a positive 14, so D would be my correct answer. So if you look, problem 5 has a little more work because instead of stealing the slope and moving on from there, we have to steal the slope and make it the complete opposite. But your steps are exactly the same. You steal the slope and keep it the same, or steal the slope and change it, and then plug in your point and your slope to point slope and solve for y.